Hey everyone. Okay, so now we're going to move into polynomial applications. Now, applications are just a fancy way of saying word problems. Okay, so we're looking at real life contexts and trying to deal with some of the math inside a real life context. Now, one of the other things that come up here, and we haven't talked about it yet if you're watching these videos in order, is this is the beginning of you having to be able to do regression on your calculator. So I will go through, I think what I'll do is I'll go through the first one using a calculator with you, and then we'll kind of troubleshoot as we go from there, okay? Okay, so let's get started. There are many real-world applications that involve polynomial functions. Sometimes you'll be given the formula and asked to solve the following information. And these are all the different things we could ask you. We could say, hey, I'm going to give you an X value, you give me the Y value. Or I'm going to give you a Y value, you give me an X value. Or we could have to solve for a maximum point. Or we could have to solve for a root, which is the same as a 0 or the same as an x-intercept. Or we could be asking to solve for a y-intercept as well, okay? And we'll go through a bunch of different examples where we'll cover all of that as we go, okay? It's really helpful on your paper to write down a legend because often they don't say, here's x, tell me y, because the context gives you different variables, okay? So maybe t is time, and that's actually your x value. Well, write that down on your paper, okay? Literally write, my x is t, and that means time, okay? Because that way you know what you're dealing with. One of the things I want you to do when you're trying to go through a question, you always want to know exactly what you've been given and what you've been asked to solve. So you're going to always ask yourself, okay, did they just give me X? Did they just give me Y? What did they just give me? Okay. Once you establish that, the rest isn't too hard. Okay, so regression analysis, you will find this breakdown on page 46 of book 1, and have it handy because we will do regression analysis for polynomials, for sinusoidal, for logarithmic, for exponential. We do it a fair amount from here on in, okay? There'll be 1 or 2 questions on your diploma that involve regression steps. Once you have the equation, you may be asked to answer some of the information listed based on your equation, okay? Okay, so here we go. First guy, a pump is used to drain a 90-gallon tank when the volume of liquid within the tank reaches a maximum safe volume. The volume of liquid in the tank, V, over a 10-hour period can be modeled by the function V equals 30t minus 3t squared, where t represents the time in hours, afternoon on a particular day. So the very first thing I would want you to say to yourself is to say, okay, V is my Y and T is my X, okay? Make sure you label what you've got. Now, the maximum safe volume of liquid in the tank can be found by analyzing the, well, what are we doing? We could graph this, okay? We could just graph it and see what it looks like. Essentially, if you do that, you're gonna get a picture that looks like this, okay? And it's saying you've got a 90-gallon tank and it's set to start dumping when it's reached a particular maximum safe volume. And so the volume's going up and up and up and up. And here we've reached the maximum safe volume. And so the pump kicks in and the pump starts getting the water out. And so the volume goes down, 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 down. Okay, so the maximum safe volume of the tank can be found by analyzing the, well, what is that? That is the vertex. But remember, we're looking at time versus volume. So do we want the t value of the vertex or do we want the v value of the vertex? Well, did they ask us for when the pump kicked in or did they ask us what the maximum volume is? They asked us what the maximum volume is. So that's your y value or your v value, okay? So it would be the v coordinate at the vertex. So the answer would be C, okay? The V coordinate at the vertex. Okay? Awesome. All right, so then to the nearest tenth of an hour, the first time the volume of liquid would reach 65 gallons. So again, you're asking yourself, okay, is 65 gallons, is that a T or is that a V? Is that a time frame or is that a volume? Okay, and it's a volume. So that means you are being given a Y value and you are asked to solve for an X value. Now, if you're a TI, you're going to type the original equation into y1 and you're going to type 65 into y2 and you get a graph that looks something like that. And then you're looking for this intersection point. Okay, that's the first time it hits a volume of 65 gallons. And so TI kids, to do that, you're going to go second trace 5, put your cursor over to here and hit enter, enter, enter. Okay, if you're a Casio kid, again, you will graph the original guy, the V equals 30t minus 3t squared. But then you can just go Gsolve and then Xcalc and type in your Y value of 65. Okay. Either way, whether you're Casio or TI, you should arrive at 3.2 when rounded to the nearest tenth of an hour. Okay, so 3.2 hours. You can see there, I posted on my screenshot, it was actually 3.1742. Okay, but when rounded to the nearest tenth, that would be 3.2 hours. Okay. All right. The path of a shot put thrown at a track and field meet is modeled by the quadratic function h of d equals that, where h is the height in meters and d is the horizontal distance. So again, I would want you to say, okay, h is my height, d is my horizontal distance, who is my x, who is my y, h is my y, and d is my x. Write that out for yourself so you have a good understanding, okay? Determine the height of the shot put when it has traveled 10 meters horizontally. So I've been given an x value here. I've been given the distance it's traveled horizontally, and I want the y value, okay? Well, those are fairly easy. You just plug in x, plug in the 10 for x, right? So we don't even have to graph this. We could just use our calculator and type it in to the regular portion of our calculator, or we could graph it. It totally doesn't matter. It's just going to be negative 0.048 bracket 10 squared minus 20.7 times 10 minus 26.28. And when I do that, I should get 6.4 when rounded to the nearest tenth. Okay, 6.4. Okay. How far has the shot put traveled when it finally hits the ground? Okay, now for that guy, if it finally hits the ground, again, I'm looking at a graph that looks something like this. Okay. It's kind of hard to see on the board there. Let me switch to a better color for you. Okay, I throw the shot put. When it finally hits the ground, I'm looking for that guy right there. Okay, so if you are a Casio kid, you can just go Gsolve root and get yourself over there. If you're a TI kid, what you want to do is you want to write y2 in y2, put it as equals 0. Okay, and what your TI will do is that will graph another line on the x-axis, and you can solve for that intersection point, just like you did a couple of examples ago. To solve for the intersection point on a TI, you'll go second trace 5, bring your cursor close to the guy you're looking for, and then enter, enter, enter. Okay, and you should get 21.9. 21.9. Okay. All right, describe the characteristics of the trend in the data. Now, when we're looking for the trend, we actually don't follow X at all because X just always goes up. We're always reading a graph from left to right. So if we're reading a graph from left to right, you're always going to see X just go up, right? Because that's what happens as I go along the x-axis. So when we're trying to describe the trend in data, we're actually looking for the Y values. So take a look at the y values. I'm going from 135 to 120 to 115 to 102 to 92 to 85 to 78. That just keeps going down and down and down and down. So it's decreasing. Okay, that's all we're looking for there. Okay. A ball is launched vertically upward from a height of 5 feet with an initial velocity of 96 feet per second. The height of the ball above the ground for the first 5 seconds is shown in the table. This data could most appropriately be modeled using, well, we could do that just based on following what y is doing. I'm going up and then I'm start going down again, okay? Just based on the fact that I'm going up and then down, that sounds quadratic, right? If it was going to be cubic, you'd want to see 2 changes of direction. So you'd want to see maybe I'm going up and then I'm going down and then I'm going up again. But because we don't see us going up again, the best thing we can do is say, hey, this is going to be a quadratic regression, okay? All right, now what we're going to do is we're actually going to figure out the regression equation, okay? And so because this is our first one together, I'm going to walk you through it with a calculator. My calculator is a Casio, but I will, if you're a TI kid, I will walk you through what you do to get the same screen in a TI, okay? So I'm just going to switch here to my calculator. Just give me 1 sec to switch over. Okay, so now you should see me and my calculator, best of buds. Okay, so to get into the lists, you have to put this table into your lists. For Casio, you're going to go into statistics, and that's where you'll see your list 1, list 2, list 3. Okay, on a TI, you're going to go stat and then edit. So stat enter. Okay. And then you'll also see the same screen here. So what you want to do is you want to put your time values or your x values into list 1. So 0, 1, 2, 3, 4, 5. Okay, if there's anything else there, just delete them. And then in list 2, you want to put your y values. So that's going to be 5, 86, 134, 150, 134, and 86. Okay. You should make sure you end up in the same spot on both lists. Otherwise, you're going to get an error. Okay. Okay. Now, for Casio kids, what you're going to do is you're going to, I always, Casio kids, I would get you to graph it first because that's going to adjust your window settings for you automatically and it's going to be really nice. So I would graph. You see the picture. And then you're just going to calculate your regression, okay? So we would calc, and we want to do a quadratic, so F4, and there's our equation, okay? I'm going to stay with Casio kids for just another minute, since I have it right here. I want you to copy it, Casio kids, and hit enter, and that will put it in Y1 for you, okay? Now, to the TI kids, I just want to walk you through the same sort of buttons, okay? I'm going to leave that Casio on my screen because that way you can compare your numbers with those numbers. They're going to be the exact same numbers, okay? So for TI kids, once you get your stuff in your lists, you're going to press stat again, and then you're going to right-click over to calc, okay? Instead of having edit highlight, you're going to go over to calc. And then you have to choose the one that you want. So a quadratic regression is option 5. You don't have to scroll all the way down to option 5. You can just press the number 5. Okay. And then depending on, there's a couple things I have to talk about here, just depending on whether you're an old operating system or a new operating system. If you're an old operating system, you want to stick Y1 right beside your quadratic regression guy. Okay, so to get Y1, you press variable, go over to Y variable, press 1 for function and 1 for Y1, and then you can hit enter. Okay, and then that should give you the same screen that you're looking at with me. On a newer operating system, when you go to do that quadratic regression, you just have a few things you can fill in, and one of them is store equation. So you're going to put your Y1 into that store equation guy. Okay. Now, I hate doing this without having you right in front of me because I don't know what to troubleshoot at the moment. I'm hoping that that went okay. If it's not though, send me an email. Watch this again, go through the steps one more time. But if you feel you're missing something, just send me an email and maybe we can troubleshoot that way, okay? Okay, so now what I want all of you to do is, I'm going to switch back to the PowerPoint slide in a second, but before we do that, actually, no, I'll come back to here. Let's just go back to the PowerPoint for a sec. Okay, so I've got an A value of negative 16.09089. I got a B value of 96.589, and I got a C value of 5.17. When I scoop back to my PowerPoint, we were asked to round those answers to the nearest hundredth. So this is the answers rounded to the nearest hundredth. Now, the point I want to make, I just got all of you to stick your equation into Y1. That is super important because any question that they ask you to do based on the equation is not based on this rounded version, okay? It's based on the actual version, which you now have stored in Y1, all of you, whether you're a TI or a Casio, okay? Okay, so the next question says, using your regression equation, determine the height of the ball at 6 seconds. So at 6 seconds, is that an X value or is that a Y value? Okay, and that's a time value, so that's an X value. Okay, so essentially you're going to go trace 6, but a couple things we need to talk about. So I'm going to switch back to the calculator for a sec. And Casio kids first. What I want you to realize when you go to graph, okay, you can see that you stuck that equation there, but it's not on. Do you see how the equal sign is not highlighted there? So you're actually going to have to press select, okay, and I actually have to deselect my Y2, okay, and then you can draw. So there you go. You're looking at the graph, and you'll notice your window settings were set up because I got you to graph the dots before the regression. So you automatically have a nice window setting. TI, you're going to press Y equals, and you're going to see the equation there, and you're going to go and graph, but you may have to adjust your window settings in order to get a picture that looks decent. So just to help you out here, my X's are going from 0 to 6 or 7, and my Y's are going from 0 to 200 would be fine. Okay. All right, now all of you, if you're given an X value, you can go trace and then enter the X value. So the X value here was 6. So you go trace 6, enter. Now, this is a great conversation to have. You may or may not have gotten an error depending on what your calculator said, but I got an error, and this is a common error to get, and I want to explain why. This is an error you're going to see on both Casio and TI, and it's because my window settings don't go all the way to 6, okay? Your calculator won't calculate something that's not in the window, okay? It doesn't mean it doesn't exist. It means your window's not showing the value that it's seeking for, okay? So I need to go to my window settings. I just need to get out of here for a sec, sorry. I need to go to my window settings and I need to change my X max. I'm just gonna change it to 7, so I know for sure I got 6 in there. Okay, so now when I go trace 6, I get 5.5. Okay, so whether you're a Casio or a TI, that's the same conversation, okay? Your window has to have the point inside it in order for your calculator to actually go get it. Okay, so now I'll go back to the PowerPoint. And we're looking at 5.5, okay? Don't forget to have units in your answer as well. Okay, using your regression equation, determine the time it takes for the ball to hit the ground. That's a root, okay? So if you're a TI kid, you're gonna go Y2 equals 0 and solve for that intersection point. If you're a Casio kid, you're gonna go G solve root, and you should get 6.1 seconds. Okay. All right, good job, guys. We're getting there. Now, next one. A rain gutter is made from sheets of aluminum that are 28 centimeters wide. The first step in forming the rain gutter is to turn the edges up to form right angles, as shown in the diagram below. The cross-sectional area formed by the turned up edges affects the water flow. The cross-sectional area A can be modeled by the function A equals x times 28 minus 2x, where x is the height of the turned up edges. So A is my y, x is my x. To the nearest centimeter, the height of the turned up edge x that will maximize the cross-sectional area. Okay, so we are going to graph this and we're going to look for a maximum. Okay, I can do that with you if you like, just if that helps. So I will share. We're going to type into y1, we're going to go x times 28 minus 2x. Okay, we're going to graph and make sure our window setting looks decent. I don't see my maximum right now. I'm also going to bring my y max down a bit and my x max way up so I can see things a little better. So I'm going to bring my x max probably to about 20. See what that does for us. And my y max, I probably am comfortable to bring it down to 125. Let's just see what that does. Yeah. Okay. So now I can see the maximum point. Actually, I can see all the important points that I want to see. So this is a decent picture. Okay. Now it says I want the x value that will maximize the cross-sectional area. So I need to find the maximum point. And I need to take the x value of that maximum point. So on a Casio, that's gsolve max. So it's 7 and 98. On a TI, what you're going to do is you're going to go second trace maximum. And then it asks for left bound and right bound. So left bound just means you're somewhere over here. And right bound just means you're somewhere over here. Okay. And then when you hit enter one more time through the guessing portion, you should also get 7,98. So again, you have to remember, what is my answer? They wanted the x value, so your answer will be 7. Okay. Awesome. Okay, determine the equation of the linear regression for the data. So again, now, I won't put the calculator up. I'm just going to walk you through by talking. So you are going to go back to stats. Go back to your list. So for a TI, that's stat edit. And for Casio, it's menu stats. Type in all your X's, type in all your Y's. For Casio, you'll go graph, graph 1, then calc, and choose your X. Then copy and hit enter. For TI, you will go stat, go over to calc, choose linear regression, which on a TI is option 4, okay? And then you want to get that Y1 beside it again. So if you're an older TI system, you'll go variable, Y variable, function Y1. And if you are a newer TI, just in the store equation section, you'll stick Y1 there. Okay, you should, if all those steps went okay for you, you should end up with B, which is 78.1x minus 1.07. Okay. All right. A hockey arena seats 1,600 people. The cost of a ticket is $10. At this price, every ticket is sold. To obtain more revenue, the area management plans to increase the ticket price. A survey was conducted to estimate the potential revenue for different ticket prices as shown below. The data above can be modeled by the equation function, or sorry, by a quadratic function of the form y equals ax squared plus bx plus c, where x is the ticket price in dollars and y is the potential revenue. So I need to do another regression, okay? Here's my x values. My y values are there. You have this in your book, but I am just going to hide myself for a quick second so you see it on the PowerPoint, because I know my big old head is in the way there. Okay, so we're going to do a quadratic regression. Have these in your x, have these in your y. So again, if you're TI, you're going stat edit, putting this in list 1 and list 2. If you're Casio, you're going menu stats, putting that in list 1, list 2. Casio kids, from there you're going to go graph, graph 1, calc, and then copy and hit enter. Or sorry, calc and then x squared for regression, and then copy and then enter. TI kids, you're gonna go stat and calc, and then choose your quadratic regression again, which is option 5. And then make sure Y1 is beside it or Y1 is in your store equation section. Okay, and you should end up with a maximum point of 20,489 with 17. Now you got to be really careful with this guy because they actually said a maximum revenue of. So the question, which is, this is kind of mean, but the question actually gave you, they asked you for your Y value first, okay? Because they said the maximum revenue and then they said the ticket price of whatever. So the ticket price was actually X. So the point you're looking at is actually 17, 20,489, but the way the question asked it, the 20,489 has to come first. Okay. Okay, my friends, that is it for polynomial characteristics. So we'll see each other again and start looking at sinusoidal stuff. Okay, take care.